So simple harmonic motion is motion which repeats itself over the same path. A slinky can do other things, but something like a pendulum will just go back and forth. Okay? A spring, it's like pretend that was kind of like a spring. Anyways, I should just break down the examples. So springs, pendulums, and swings. Okay? And we abbreviate simple harmonic motion as SHM. So you can leave or behave. Two options. Okay. So when I say SHM, I mean simple harmonic motion. If an object has a repeating pattern, then the object will also have period and frequency. So let's remember what period and frequency are. So period is t, the time it takes to make one full circle or one complete pattern. So let's abbreviate or kind of put this as t is equal to time over one circle or pattern. T is equal to time over one circle or pattern. So the way that I remember that is like T is measured like in seconds. So the value on the top needs to be time. So time goes on top for T. But then frequency, the thing that was different about that is it's the number of complete circles that can be done in 1 second. So F is equal to number of circles in 1 second. And before we measured that in hertz. To convert between the two, remember we can go F is equal to 1 over T to convert between them. I don't think so. We can double check. But wouldn't it be the same? Yeah, they should be the same. Because they're both inverse reactions, or inverse relationships, so T would equal 1 over F, and F is 1 over T. That makes sense, right? Okay. But if you already memorized the T equals 1 over F, just you can stay with that. Yeah. So since a spring and a pendulum have SHM, we can calculate the period of a spring and a pendulum. So this period of a spring, so we need to use our spring knowledge, which includes the spring constant. So this is a formula that we need. So now pull out your formula sheets. Let's see what we got on there. Look under, we're now under waves. Okay, so under the waves section, that's where we see our formula. So you don't need to memorize this. This is on your formula sheet. So you can give it up to that. This is on data sheet. So that's nice. And then we can also calculate the period of a pendulum, where L here is the length of the pendulum. So this space, that's L. G is the acceleration due to gravity, which we always know, and T is our period in seconds. And this is also on your data booklet, so find this one too. You'll note it there under the waves section. Okay, you can flip your page. And then we'll do the first example.